Everybody, welcome back. We've got another tool edition clamping kit for the mill. One of the projects you can start early on is making clamping kits of your own. But I thought in order to get started, just to get a variety of different pieces, I'm going to go ahead and purchase one. I went back and forth again. Like everything else, you need to do your research and make sure that the version of this that you buy will fit your table. Hopefully I did the right research. You know, the table slots, even though the dials and the lead screws and inches, there's still a lot of metric components on the mill. These all measure like 7/16, close to 12 millimeter. Anyway, they make them in all different sizes, right? Bigger lathes, bigger T-slots, and you have different size kits that you need. But I think this is the one that I needed. Let's go ahead and open it up, and we're going to verify together. It's one of these, if you look on eBay or Amazon, they have them with the red and blue cases or holders for all the parts, and some of them have different stud sizes. Just pay attention to what you're ordering, because it might not be the actual set that works for your T-slots. Hopefully I did the right research. Let's find out. Let's open this thing up. Trying not to destroy it. There we go. There we are. Let's pull this out of here. Maybe. Here's how it comes. Nice box. It's actually packed for what it is. It's packed pretty well, I think. Rubber band to keep that on. You've got your T, all of your T studs, not your T, your studs, and then the rest are just all your components in here. A little bit oily. Let's get my mat down here. And this is something you can, of course, hang on the wall. But what we really want to do is test these T-nuts, make sure they're going to fit in there. That was the biggest concern I had. Everything else, of course, you can, hook together as you're clamping down your parts. But like I said, the T-nuts were the thing that I really wanted to make sure we're going to work out. So there they are. Let's see if these T-nuts are going to fit over here on the... Here's one of the T-slot T-nuts, and there's some give in there, but they fit. That'll hold down our material. Yep, there we go. They're not a super tight fit, but I don't think this set is designed to be that way. One thing that's worth noting, you got to be careful with this style. If you were to tighten these down too far, there's a through hole in there, and you could theoretically damage your table. So you really need to be careful when you're tightening these down, tighten down your things, to make sure you don't puncture a hole or ruin your table. But there we go. So they fit. So that'll allow me to fasten things down. And you got one of these numbers, and you put that down, and then you can put your part in there, and then you can clamp it all down as you need. So that's the idea. With this area over here on the milling table, I've got that for unique parts, things that need a special clamp. That's where this kit will come in handy. And for no more than it was, I thought, let's go ahead and get one of those so I can complete most of the tooling, tooling that I need, and we'll be good to go. All right, let's get these cleaned up and organized, and then we can get it mounted on a wall. So it comes with varying size of studs, T-nuts. Those are basically where they need to be. Comes with some nice flange nuts for when you're tightening down to your milling table. So those will be handy for that. If for some reason you need to extend some of this stuff, hook a couple of these together. You know, you've got options there. That's it's supposed to just have a lot of variety for just the who knows type scenario, whatever you're trying to clamp down. You can't predict everything, so it just comes with a variety of items. What else did we get? So here's one of those clamps. So here's the two larger toe clamps, I'm going to call them. Here's two smaller ones. All the studs we'll put in here in a minute. We've got several of these angle clamps, and again, these are for when you put down on the table. You can clamp mostly the toes and let you crank that stuff down. But there's 8 of these, I believe. Yeah, or 4. There's a smaller toe clamp, and we got some other angle blocks. Again, it's all about just the varying scenarios that you might run into. And then we have our studs. Let's get these out here. So I'm pretty sure, well, I want to put these on in a minute. Let's get all of our different studs out. Pretty short ones. And even longer ones. Yeah. There's a flaw in that one. This one is not threaded. That's not going to work. Quality on these is not the greatest. I might email them, see if there's any way, but it's just simply not threaded. So that's a useless bar. So go through all your parts if you order a set like this. It's not going to be perfect. Some little ones and 4 larger ones. So they're pretty oiled up. That's the set. If you order one of these, check your parts. Like I said, you can see there's no threads. Anyway, that's what you get. 7/16 I think is what it was listed on the ad to fit these 12mm slots. So it appears we aren't done with this clamping kit yet. As you can see, they sent one. This is a flaw. This end of one of the 6-inch studs is not threaded. So I reached out to the reseller. This was, in full disclosure on this one, I bought it from eBay. I think it was Find Mall. You've probably seen them if you've looked at any of this kind of stuff, accessories for lathes and mills. But in this case, they responded, and of course they offered, you know, they don't make this stuff. They don't have shelves of parts. I asked them to send me a stud. That's all I want. 6-inch stud that's properly threaded. They said, would you take monetary compensation? I said, well, I would prefer a working, fully functional set that I purchased that has all workable components in it. But then I also asked, I said, well, what do you want to, what's the compensation? You know, if it's $1 or something, no, send me another set. But in this case, the main reason is I don't know how hard these are. I don't want to ruin my dies. So I'm going to use a Harbor Freight die. And if I ruin that die, I really don't care. So in the meantime, I'm waiting on their response. I'm going to go ahead and attempt to thread this with my Harbor Freight dies. I went ahead and checked the thread pitch. I mean, you can look on the box and find out what they are, but I like to confirm. This is a 16 thread pitch, standard SAE. This is not metric, which is one of the rare, it's kind of weird. Everything is metric that you buy, not these. And then it's a 3/8 inch die thread. So that's what we're going to use, and I'm going to set this up in the lathe, try to get that as concentric as I can, and we'll try to rethread this on our own, and then we'll see what they say in the meantime. Anyway, let's get you set over in the lathe, and we'll work on trying to thread this thing out. run it through the other way, but there is like no peaks on this thing. I don't know. It's pretty trashy. I'm going to run it through this way though. Maybe this will work out if I run it backwards. Let's get this ran through and see if that improves the thread at all. But I think if I still don't like it, I'll use my Irwin on this, and we'll continue on from there. See if that makes it better. Let's just clean this up though and see what it looks like with a test fit. Alright, let's give this another shot. I'm going to use my Irwin. We'll see if this can clean it up a little bit better. But, yeah, that's... I don't know if it can or not. I don't know if there's not enough material here or if it was the dies. Let's see. I mean, that goes on. There's just not enough material, so the rod itself was screwed up. So the Irwins aren't even going to fix that. There's no point in messing with that. Unless it's not 3/8, but I know these are 3/8. Yeah, that's the best I can do with this. So ideally, I need a new rod, or I need them to send me another one. The fix is not, I can't fix this rod. Anyway, we'll clean this up. I'll bring you over to the bench and show you close up what's going on with this. Alright, we're going to close this video out, but I'll show you what we're dealing with here. This is how it's supposed to come. You know, you can see the threads. The flange nut goes on there, so you can mount down your material. So I thought, well, they're offering money, but in the meantime, I'll see if I can money to compensate for this. But I think they just screwed up when they machined this, and there's just not enough. You can see there's not enough peaks. There's not enough material to make a proper thread anymore on this. So this rod is ruined, or it's junk. But yeah, this can go thread in, but there's maybe 25% thread engagement. You know, it's a very loose fit. So that could easily strip out if you're trying to tighten a part down. I wouldn't trust this stud for working on a workpiece that needs to have accuracy and precision. So anyway, we'll see what Fine Mall says. They'll probably just give me monetary compensation, but anyway, I thought I'd follow up with that. Check your parts when you're ordering this cheap stuff. Something's not going to be right down the line at some point. Anyway, thanks for watching. Hey everybody, welcome back. Today we're going to continue on the kind of the initial series of the mill. Not doing a lot of projects yet. I did do a little one before where I tightened up improved a handle that I had made with some flat so I could tighten it up. This project is something that I want to work on, and it is practicing finding the center of any particular piece of workpiece that you're working on. If you recall, I've got a couple wigglers or center finders. You know, they run off center, and then once they reach true, they run center. You can find your center. You put your DRO one side, find the other side, and off you go. So I have a Brown & Sharp that was given to me. This is a 3/8. This one's a 3/8, and the other one, don't really need to use them both, but the other one I think is a 1/2 inch. I went with a bigger one in case yeah, this is a 1/2 inch. So again, the same concept applies. This is a Mitutoyo. I bought that off of eBay, Amazon actually. And I thought, you know, who knows, maybe I need a second one, different size. But at any rate, they both are going to do the same thing. So we're going to use this Brown & Sharp. It's got the 3/8 shaft, and we'll use the collet chuck that I have with the 3/8 collet, and we'll mount everything up over here, and we will try to center in this piece. I want to find the center point of this piece. We have our center finder. We have our block of aluminum. Let's get some parallels in here, and we'll get that mounted up. There. Good. That should fit in there nicely. It does. Now we need to bring out our nut. Put this in here. Hopefully you can see that. Yep. So I'm going to tighten that up a little bit. I don't think it needs to be too aggressively tight, but I do want it to be snug. There, that's not going to come out of there. So we're going to try to find the center using the DRO. So what we're going to do is center in the X and the Y axis and try to find the center of this block. All right, we're going to get the machine turned on and get this wiggling and then touch off. All right. All right. So that would be X. Let's clear that. Let's check one more time. So we're about 7/10 off. Let me try that again. There. And finally, one more. All right, got that side done. Raise up. And bring that back down. Okay, let's check this side. Let's do it again. Alright, so we're trying to find the center of this block on the x-axis. We have our x-axis total length, and what we want to do is half that. So there. So now let's do the y-axis. All right. Let's try it that way. Very touchy. That's about perfect, but let's get it to pop. There we go. So we clear our Y. Up. And now let's check this side. Really close. My piece might be a little too wide. Let's be careful here. Make sure I don't damage this wiggler at all. Okay. So I'm a little bit too far, so what I should have used is a spacer on this side to bring the workpiece. Actually, no, I need it to go that far. So that's something I need to consider for future projects. I can't really, I'm using this vise, I can't really get past, you know, there's 2 inches or so of this milling table that I can't come over and use. I don't know if it's because of the DRO or some of the other stuff that we have on here. Alright, I don't want to damage the wiggler at all, so I'm just going to manually measure this one. It's 3 I would use the caliper, and it's 3 inches 482 thou. So what I'm going to do is cheat with the x-axis. I'm going to come over the full 3 inches 482 thou, if I can, and I'll show you why I'm doing it this way. Now, why am I doing that? I've got maybe some adjustments to make with as I use the mill and I work on different projects. There's a metal flange back here that holds this accordion cover on, and it's hitting the back of my vise. So I lost, well, I assume this flange would go on over the top of the table, but if not, I lost, regardless, I lost about a ½ inch of travel, and I'm already suffering here. And with that, if it goes under there, then that would be my 1.5 inches, 2 inches that I lost on the front side. So I think a lot of folks battle this kind of stuff, but I'll improve it over time. I'll find out what works, what doesn't. But at any rate, I'm just going to go with the manual method here. I measured it, 482 thou, 3 inches 482. Again, I'm going to use the DRO, and we're going to center it, and then we'll find the center on both X and Y axis. There's our Y axis on the DRO. We're going to zero it out, or half it. And there we go. So now we need to put our X and Y axes on 0, and that should be the center point. But before we do that, I'm going to put a pointer or center bit or something, probably a center drill, and that way we can mark the piece with the center, and then we can do some measurements with it. Maybe. I don't think that's gonna work. It's just too small. Need to come up with something else. Okay, this is not ideal. We have a 3/8 drill bit, but for today's test and my learning, this is what we're going to use. I think we're going to be able to find a pretty accurate center point with this. Let's bring this over, 0 on the X and 0 on the Y, and we'll center up this drill bit. Of course, we got to go the right way. We're wanting as close to 0 as we can get that. Almost there. Okay. And then the Y, we want as close to 0 as we can get it. It's tough. I mean, that's basically it, but if I try to move it a little, it'll go too far. Yeah, see. So we're gonna go with that. We're gonna call that 0. I mean, it looks good. Let's put a little dimple there. And again, that's not an accurate drill bit. It's not going to be perfect, but this is going to give me the idea, and then we'll do some measurements on the bench. And I'm going to use the quill. That's all I need, just a spot. So I'm going to take this out and we're going to bring it over to the bench and we're just going to do some measurements and see how we did. All right, everybody, let's close out this video. Again, this was me testing using a center finder, and I've learned some things. You got to have enough travel in your workpiece. This is a decent sized mill for what I need. I just need to think outside the box, I think, for some larger workpieces. I may end up having to readjust for certain things, but for the most part, I've learned I need to pay attention when I'm working on things about the distances that I may need to perform an operation. But this worked out very well. Thank you for sending that and sharing that. That's definitely going to be used quite a bit. That DRO, to be able to just center it and half it on the fly like that, that's just going to be a game changer for trying to find accurate centers. This should be pretty good. I didn't have enough travel on the 3.5-inch side y-axis, so it's not going to be perfect. Plus the drill bit that I used, it it could have wobbled a little bit, but let's do our best to use. Let's first use the scale and eyeball it here. That is just shy of 2 inches, 1/32. I mean, it's a 32nd shy of 2 inches on this side. Let's flip it over 180 degrees and let's eyeball it again. This is not precision, and it's also just this is the 32nd side. We're 1/32 shy of center. I'm satisfied that the this was the x-axis. The x-axis is centered. The y, who knows? I may have screwed that up. Let's see. Do the same test. That is way off. 1 inch. So I screwed up somewhere. That's 1 inch 21/32. Yeah, it doesn't look centered at all. I screwed that up big time. So my y-axis was definitely not centered. I messed that up, but I knew it was going to be because I ran into that little hurdle. Yeah, that's 1 inch 659 thou 660. And this is, I could tell you it's way off already. Yep. So let's not worry about the y-axis. This is just me testing further on this block that I squared up. But my x-axis, I'm satisfied, is centered. Let's see if we can actually check it with this. So that's 1 inch 985 thou. Let's lock it. Let's see how this looks. That's it. That's centered in that hole. I'm pretty happy with that. So the DRO, I've got that kind of figured out. Turn this off. So what did we do today? Well, we messed around with some clamps, clamping kit, discovered a problem with it. I tried to rethread it. So that'll be fine. And then we have our center testing. I learned how to use a center finder as well as centered in a block on an x-axis, not the y-axis. And I'm satisfied that that is a left to right x-axis, this longer side. That's center point. Anyway, thanks for watching. Thanks for sticking with me as I learned the machine, learned some of the new tools that go with the machine that I didn't use on the mill or the lathe. And I hope you stick with me. I'm having fun with this thing. There's going to be a lot of cool projects I'm going to be able to work on in conjunction with both pieces of equipment. So thanks for watching. Hope you enjoyed, and I hope to see you on the next one.